Hello, this is Mrs. Ross, and this is Lesson 13, Problems About Equal Groups. Again, that just means we've got more word problems that we're going to be doing. These are the starred problems in Lesson 13, and you'll find them starting on page 90 in the Saxon Course 2 textbook. Let's get started. Okay, we got this. Do not be afraid. Number 1. In 1990, the population of Alabaster, Alabama was 14,619. By 2002, the population had increased to 24,877. How much greater was the population of Alabaster in 2002? So in 1990, we have 14,600 that, and in 2002, we have 24,877. And I'm going to subtract to find the difference. Okay. Let's see. 2, 4, 8, 11, minus 1, 4, 6, 5, 1. Okay. There we go. So there's 10,258 more people in Alabaster, Alabama than there were in 1990. Okay, number 2. Let me go ahead and change colors here. Write 2.5 as an improper fraction. So that's the first thing we're going to do. And then multiply the improper fraction by 1/3. So we have kind of 2 steps here. Let's go ahead and popcorn our mixed number to make it an improper fraction. Multiply, add. 2 times 2 is 4, plus 1 is 5. And then I need to take this and multiply it by 1/3. And there we go. 5 times 1 is 5, 2 times 3 is 6, and that's what we get. All right, change colors. Number 3, President Franklin D. Roosevelt was 50 years old when he was elected, I don't know what cut off there, in 1932. What year was he born? So if he was 50 in 1932, I'm going to subtract those 50 years to find out when he was 0. Minus 50. So he was born in 1882. Okay. Number 4. The beach balls were packed 12 in each case. If there were 75 cases, if 75 cases were delivered, how many beach balls were there in all, or total? Okay, so let's kind of draw this out a little bit. So if I have a case, 1, 2, 3, 4, 1. So this is one case. It has 12 beach balls. Okay, if I draw another case with the beach balls, how many am I going to have? So if 2 cases, I have 12 times 2, which is 24. Ooh. Okay, so what I need to find out is if I have 75 total cases, I'm going to multiply it times 12 to find the total number of beach balls. Okay, so 75 times 12, 900 beach balls. Where is the party? That's awesome. All right, next one. 120 poles were needed to construct the new pier. If each truckload contained 8 poles, how many truckloads were needed? So great. I'm going to draw a truck. This is a truck. And it has 1, 2, 3, 4, 5, 6, 7, 8 poles on it. So I have 2 trucks. 1, 2, 3, 4, 5, 6, 7, 8. So then I have a total of 16. Right? So each time I add a truck, I add 8 poles, right? So it says how many truckloads were needed. What I'm going to do is I'm going to divide 120 by 8 to figure out how many trucks I need. And I need 15 trucks. So if I do 15 times 8, I get the 120 poles that I needed. Okay? Let's change colors. All right, write a word problem about equal groups that fits this equation, then answer the problem. So we will have to answer it. All right, let's see. Mrs. Ross bought 5 cakes from Margie's, and she ate them all. She spent a total of $63.75. How much was each cake? Okay, so what I'm going to do here is I'm going to actually divide, because you see this is 5 times t is equal to $63.75, so I'm going to divide both sides. Okay, 5 over 5 cancels. I get t is equal to 63.75 divided by 5. I'm going to do that on my handy dandy calculator. 12.75. So each cake was $12.75. That's a bargain, people. Okay. Number 7. The product. What's the product? The product is the answer to a multiplication problem of 5 and 8. So I'm going to go ahead and 5 times 8 is 40. Is how much greater? So it looks like I'm going to be finding the difference, which is the answer to a subtraction problem. Then the sum, the answer to an addition problem, of 5 and 8. So 5 plus 8 is equal to 13. And I want to know what the difference is. 27. Okay, my suggestion with these problems is to, again, interpret or decode the English sentence into a math sentence. Okay? As you saw, each word that I came across, does that have a math meaning? Okay. Number 12a. What fractions or mixed numbers are represented by points A and B on the line? Okay, let's see. So we have 0, 1, 2, 3, 4, 5, 6, 7. So that each one of these is 1 7, 2 7, 3 7s, 4 7s, 5 7s. So A is equal to 6 7s. 1, 2, 3, 4. So this is 1 7th, 2 7ths, 3 7ths. So B is equal to, see, now we're past 1, so it's going to be 1 and 4 7ths. To find AB, well, let's just count the 7ths. Okay, so from A, we have 1 7th, 2 7ths, 3 7ths, 4 7ths, 5 7ths. So, oops. So AB is 5 7ths. All right. 22, we're going to multiply across the top and then multiply across the bottom. So 5 times 5 is 25. 3 times 2 is 6. And then we're going to divide. 6 goes into 25 4 times. With 1 left over, 4 and 1/6. All right, 23, we're going to do our parentheses first because of PEMDAS, order of operations. So I have 1 and 1/5 plus 2/5, which is equal to 1 and 3/5. So I have 3 and 4/5 minus the, so I brought this down. So 3 and 4/5 minus 1 and 3/5. 4 minus 3 is 1. We keep our denominator. 3 minus 1 is 2. All right, let's change colors. Mr. Lim bought 6 dozen eggs. Now remember, this is 6 times 12, which is 72, because dozen is 12, to make sandwiches for the school picnic. He used all but 17 eggs. So this is our total eggs, and this is what we have left. How many eggs did he use? So if he had 72 eggs total and he had 17 left, I'm going to subtract. He used 55 eggs. Good gravy. All right, change color. 28. What is the product of 11/12 and its reciprocal? So the reciprocal of 11/12 is 12 over 11. And product is the answer to a multiplication problem. So let's do that. What is 12 times 11? 132. So what I end up getting is 132 over 132, which is 1. What property is illustrated by the multiplication in part A? It's the inverse property. Whenever we multiply by the reciprocal, it's the inverse property. All right, last problems. Oh, I just did this one. So, did on other page. Did already. Sneaky sneaker. Okay, refer to the figure to the right for 29 and 30. Name the obtuse, so this is greater than 90 degrees, less than. And make sure you write this somewhere in the back of your spiral so that you can look at it when you're taking a quiz or a test or what have you. And then this is 90 degrees. So let's see, greater than 90 degrees, that looks like a good one. So if I'm going to name this angle, my obtuse angle, D has to be in the middle, because that's what we call the vertex or the corner, what have you. So ADC, or I can write it CDA. As long as D's in the middle, we're good. So we got obtuse. Let's look for an acute angle. Well, let's spell acute. Okay. This one looks like it's less than. So that's going to be angle DAB. I guess you could just say angle A, and I guess up here you could just say angle D instead of getting all crazy with it. That's fine. And then you have two right angles, angle B and angle C. Okay, we don't have to get crazy with it yet. All right, let's look at this terminology. I'm going to change colors here. It says AB, which is this right here. This means parallel. What is parallel to AB? It's a line that's never going to touch it. So we know it's not DA, we know it's not CB. So we know DC is parallel. So we can say DC, or we can call it CD. Either way works. And then, I wanted to change colors again. This is a symbol that means perpendicular. Perpendicular, parallel. So perpendicular means that it makes a right angle. So perpendicular to AB, that's going to be, here's the right angle right there, so it's going to be this one, because this is not a right angle. So that's CB, BC. And those are all the starred problems we have for lesson 13. If you have any questions, please let me know. Have a great day.